Hey guys, it's Mr. Riz, and we're going to talk about this last section, P.7, which is all about logarithms and exponents as well. Let's get started. Okay, so here we have basic rules of exponents, which you guys should know, but wouldn't be a bad idea to write this down so you got them. Alright, when we have two powers, like bases multiplied, we add the exponents. When we divide them, subtract them, we always do top minus bottom. When we got a power to a power, you multiply. If we're ever taking any powers and we're taking a product to a power, we distribute. Same thing goes with a fraction. We distribute to the top and to the bottom. Now, if we ever have a term to the negative power, it switches it to the bottom. Also, if we have 1 over x to the negative a power, switches that up to the top. And that becomes x to the a. Perfect. And a big thing here, anything to the 0 power is 1. So we can start to have problems that look like this. If we have 3 to the x equals 81, what we're going to have to do first is to get like bases. And we're going to leave it at 3x because that base doesn't change at all. But 81 we can think of, though, that's 9 squared. And so really it's 9 squared squared or 3 squared squared. So it's 3 to the 4th power. And so now that we have like bases, basically they cancel each other out and we get x equals 4. Cool. Alright, we could also have another problem, like x to the 3/4 power equals 8. Alright, now in order to get this 3/4 power, what we're going to have to do is basically take it to the 4/3 power. And we're going to take both sides to the 4/3 power. Now the reason why we do that is, excuse me, when we multiply, those are reciprocals, and so they'll cancel each other. So we get x equals 8 to the 4/3 power. Now you can type that in a calculator, or what that is x to the cube root of 8 to the 4th power. So one thing we can do here, really that's 8 times 8 times 8. So we got at least one set of 8 and then another 8, which breaks down to 2 times 2 times 2. And so we have an 8 and a 2 come out, x equals 16. That's how you do it shorthand. I wouldn't mind just plug it into a calculator. That'd probably be a whole lot easier. So there's exponents. Next, logarithms. So this works for logs and natural logs as well, because natural logs are just log base e. Alright, but if we have two logs being multiplied, so multiple bases, we can split those up in addition. The same works if we want to go inside. So if we have same log base numbers and they're being added to each other, we can multiply them in one single log unit. If we have division, it's subtraction. It's always top minus the bottom, just like in exponents. And if we have something to the power of, it's being multiplied out in front. So I'll show you some of those problems that you guys could see. Could look something like this. Alright, so here we're going to express log of x squared w over yz cubed. Well, what we know is that since we have division here, we can break that up to the top minus the bottom. So there's the rule 2. Now, if we look at the top, x squared times w, we got x squared times w, and any top part we can multiply. Or not, any multiplication we can change to addition. So we did that on the top part, and we did it on the bottom part. Now we have to be careful here because there's the negative. We have to distribute to the whole bottom part. So last part, rule 3, x squared. Remember, we can bring that out in front to become 2 log of x. We still got our log of w. Now distribute, minus log, and then the z cubed becomes 3 log z. Not too bad. Now if we ever need to go the other way, and give you an example. Alright, so if we have 4 ln x plus ln 6 minus 5 ln y, First, I like to just get the multiplication out of the way. So really we got ln of x to the fourth plus ln of 6 minus ln of y to the fifth. Now, what we're going to have to do is group the additions together, and remember there'll be multiplication on the inside, and this minus sign is going to make a division. So we get ln of x squared, or x to the fourth, times 6, which we'll clean up, and then divided by ln, or not ln, y to the fifth power. So really what we have is ln of 6x to the fourth over y to the fifth. So just working backwards a little bit. Excuse me. Now the next thing that we got to do is solve equations. So we'll do some simple ones here. And we'll do exact answers, but we'll talk about them using calculators. So we have the equation e to the negative 2x power equals 5. Now what we got to remember is that e and ln cancel each other out. So if I do the ln of e to the negative 2x equals, I have to do the ln to both sides, ln of 5. Alright, so those are going to cancel each other out, so we get the negative 2x equals ln of 5. Now ln of 5 is an irrational number, it goes on forever, no pattern, so we're just going to leave it like that. Next thing, we divide by negative 2, so x equals the ln of 5 divided by negative 2. Now if you want to type that in the calculator, you get something like negative 0.8047, which is okay, but I kind of like this answer a little bit more. It's slightly neater. I know where it came from. Alright, now the other thing, here's another tough one a lot of people make a mistake on. Now a lot of people make the mistake of this problem, natural log of 2 plus the natural log of x equals 6, because they think, alright, since this is a number, and I could actually type that in a calculator, all I need to do is figure out this, subtract that from 6, and then do the e to that power to get rid of that. Which is kind of true, but what we have to remember here, since these have common bases, they're both natural logs, we can group this together as one equation, as just the natural log of 2x equals 6. So that way, when we take e to the power of both of these, cancels out those, we get 2x equals e to the 6th power. And then all we need to do is divide by 2. So x equals 1/2 e to the 6th power. I think that's a lot nicer answer than what we would have got before, but we still would have got the same decimal place, which is about 201.7. Would have got about the same, but that answer looks a whole lot nicer. Alright, this is the last section. Actually pretty easy, I believe. Not nearly as difficult as the other one. Alright, if you're stuck, let me know. Good luck, because we got the first test coming up right after this.